Hi, welcome to University of Richmond's Museum-in-a-Box. I am Martha Wright, Assistant Curator of Academic and Public Engagement here with the University of Richmond Museums. Today's Museum-in-a-Box is all about mollusks and coral. This box is a lot of fun to explore with students because you can do so much more than just look at the beautiful nature of shells, but you can touch them and hold them and sense the differences between, say, a terrestrial shell, a marine shell, and a fossil of a shell. Our plan with this box is to give you the opportunity to explore the multiple kinds of mollusks and the varieties of coral that can be found in the world. However, coral is no longer allowed to be collected because it is illegal to do so. So the pieces that we have are from the collection that came to us before it was made illegal to go hunting for coral in the ocean. Our mollusks as well come from a variety of collectors who have both found and purchased shells for many decades or across many decades and have then given them to the University Museum's collection. We understand that not everyone's able to be here with us present in person, so even though you're not able to touch them, we hope that the close-up pictures that we provide in the video today will give you a sense of the amazing, unique qualities of the different kinds of mollusks. Let's explore these 5 classes of snails. So let's begin. Starting with the history of mollusks, they go back a very long time. If you think about life on Earth, it really did start in the ocean, and mollusks are no different. Some of the earliest shells that we have found are going to be gastropods and bivalves, which date back to the early Cambrian period of about 540 to about 480 million years ago. The next amazing variety of mollusks that we find are going to be cephalopods, which go back to the Cambrian period, and we start to see them really around 490 million years ago. With another section of cephalopods, which we'll be talking about today, ammonites, that then become the now modern nautilus. Those ammonites don't really start until the Devonian period, which happens to be about 416 million years ago. And then, of course, the nautilus shells that we have today in modern times are going to be much later. We're looking at the Cretaceous period, about 140 million years ago. Looking at these fossils, we start to learn a lot about shells. Not only how many different kinds there were and how old they are, but how very little will change over a long period of time. We see evolution on land, stressors such as environment, conditions for growing food for herbivores, or rather presence of herbivores for carnivores to eat, weather changes, all sorts of pressures can force over long periods of times evolution of a species. In the ocean, sure, there have been changes. There has been global warming and cooling, which can affect the sea levels. But in terms of the environment, the changes are not going to be as drastic in the ocean as they are on land. And so we don't see a tremendous variety in, say, something like a scallop from anywhere from 9 to 16 million years ago that we may find in a scallop today. They can still be very similar. But the scallops of old tell us about the time that has happened before humans. And so these scallops, if you're in Virginia, you will be happy to know that the Chesapeake jeffersonius is in fact the state fossil. The Chesapeake jeffersonius was named after 2 things for Virginia. One, the Chesapeake Bay, where the shell was found, and also Thomas Jefferson. Though he was not the one to find them, his love of natural sciences and of course being a very important person in the history of Virginia and this country is why they gave the name to the shell. So these shells show up all over Virginia from the times when the sea level was all the way up to Richmond and now to where it is over by the Chesapeake Bay and Norfolk area. So we find these shells all around, showing us that not only of times before humans lived here, but where the water was, where the land was. And that's very important because a lot of times you can find fossils such as these in land areas without seabeds or riverbeds. And that tells you a lot about how the land itself has changed over time. This fossil, while the scallop itself is intact, the shell has not been pried open, and the fossilization process kept it intact, so it's actually quite difficult. Well, you can't open it without breaking it. But it does have a hole here, which could give us the opportunity to theorize that perhaps the scallop animal that lived inside of the shell, the mollusk that lived in the shell, was perhaps eaten from the inside out. This hole here, presumably created by a predatory mollusk or perhaps another animal, would have used either a rock, if it's, say, a land animal, to crack the shell and eat the animal from the inside, or if it was a predatory mollusk, they would use their radula, or a sharp tooth, mouth appendage, to break a hole into the shell and eat the animal inside. So fossils can also tell us a lot about how these shells would have, or rather the animals, the mollusks in these shells, might have lived, where they lived, and perhaps how they died. So there are different kinds of mollusks. There are, of course, bivalves, gastropods, but we're going to start with the other ones first. The first ones I want to mention is the nautilus shell. The nautilus, while living today, you can see perfect examples of it and videos of how they swim. The nautilus is an example of a cephalopod. A cephalopod is going to be animals such as octopus, squid, cuttlefish, and of course the nautilus. And there's more than that, but nonetheless, these are the major groupings of cephalopod. And if you break the Latin words up, ceph means head, and pod means foot. Head foot. The nautilus is going to be part of the class cephalopod. And cephalopods are one of the many kind of mollusks that we'll be seeing here today. Cephalopods can include squid, octopus, cuttlefish, and the nautilus. But what does that name mean? Well, ceph means head, and poda, or pod, means foot. And it means that the tentacles, the feet, are attached directly to the head. They are invertebrates, and so these soft-bodied creatures do indeed have a bone, and the bone happens to be in their head, which is why when they die and are preserved in some way, whether if they were to be fossilized or not, we don't see the soft body fossilized, we see the bone. So you oftentimes will see cuttlefish bones used for birds because they like to chew the bones. But the bone is inside the head and the foot is attached to the head, cephalopod. But they, like other mollusks, are invertebrates, they do have mantles, and they have 3 distinct body parts. The nautilus here I want to show because it's really neat if you watch on a video how they swim. They don't necessarily swim the way that you see an octopus or a squid with very great speeds and ability to turn on a dime. These guys have to use the chambers inside of their shell to swim. So what they do is if they need to float, they decrease the liquid that is in these chambers and increase the air, bringing them up to water's top, right? And if they need to sink, they flood their chambers with liquid, making them heavier and dropping down into the water. In real life, if you were to see a nautilus, you wouldn't see the inside of the shell, but you would see the outside. And the eyeball is somewhere around here, and about 90 tentacles come out of the front. So how does this relate back to the fossils? Well, we do have fossils of those ammonites, which I mentioned, from the Devonian period of 416-ish million years ago. The ammonites are the same construction, right? They have those chambers, but these fossils show us, of course the chambers here, but the fossils show us not only how big they could be as well as how small, but how old they are. So what happened? Well, at a time of great global cooling, these ammonites, the vast majority of species, died off. But there were some that were able to sink, and I think it's about 7. This is kind of a loose understanding. They dropped down deep enough where they could stay warm and find food to stay nourished over long periods of times, which then led to, of course, evolution. So even though the ammonites start in one way, Eventually, we do see the resurgence of a very similar type of cephalopod in the nautilus, though they are not technically ammonites because, of course, evolution changed them over very long periods of time. The next mollusk that I'm going to be showing you very briefly is called a chiton or chiton, C-H-I-T-O-N. But these Latin names are Polyplaca thora. Poly, many, placa, plate. And chitons are known for having 8 plates along the back to make their body, or rather to cover their body. Because keep in mind, mollusks are soft-bodied creatures, right, that have this mantle and these 3 body parts, or 3 distinct parts of their body. Here, the chiton has these hard shell plates created on the back, so that way it can be protected from predators, etc. Chitons have a mouth appendage, which is a little bit like a tooth, called a radula. And this mollusk uses the radula to scrape bacteria and algae off of rocks to eat. And sometimes they eat sponges. Not the kitchen sponge, little sea sponges, which are animals. And they often come out during twilight hours. They can come in all sorts of colors and sizes, and some of which will even have little hair-like growths on the outside that gives it kind of a wavy look, even though it does still have the 8 shell plates. Another mollusk, which I cannot show you because we do not have an example of it in the box, is called a nudibranch. A nudibranch is a mollusk that has no shell, but they come in a variety of colors and sizes and, well, always the same general shape. It has that slug worm-like shape to it, like you see in most mollusks. So the nudibranch, which has no shell, will come in a variety of sizes and colors, oftentimes with little body add-ons. They look like spikes, but they'd be soft, and they come in bright, vibrant colors too. And the reason why they do that is so that they can look poisonous. If you come across a snail that is bright red or bright purple, you're likely going to be very hesitant to eat it because you don't want to be poisoned. Well, nudibranches do a really great job of using colors to help protect them from predators. Nudibranches also have a radula, like many of the other mollusks, to use to scrape food, but also to use to penetrate the shells of other mollusks so they may eat them. Another mollusk I want to show you is called the tusk, also known as a scaphopoda. The scaph means boat and poda, foot, because the foot that connects to the body, which we see inside of the shell, well, the shell looks like a boat or a tusk. So if you think about elephant tusks, right, they look just like that. But scaphopoda, or tusks, are a little bit different. They like to dig themselves underneath the sand level, so that way you would only see the top, but you would not necessarily see the mollusk inside the shell. What this mollusk does is uses their little foot ripples to move along underneath the sand and search for maybe little eggs or baby mollusks that haven't grown large enough or are living under the sand level. They also may eat bacteria and other small bits of sea life that are existing underneath the sand level. Something that's very neat about squid and octopus that many people are aware of is that they can change their color. They have something called chromatophores, where these little sac of, almost like liquid sacs or jelly sacs in their skin, little circles that will expand or contract depending on how their mood is, if they are in danger, or just environmental reasons that will change their color to respond to the situation. Octopus also have 8 arms, and squid, while also having 8 arms, have 2 tentacles. Both of these groups, as well as cuttlefish, will use their arms and or tentacles to bring in prey and eat. Something that is uniform across all mollusks is a mantle. And I know I mentioned that with all of these is that the mantle is present either as the body or inside the shell. For cephalopods, a lot of times if they don't have an external shell, such as a squid, an octopus, or a cuttlefish, their mantle is going to make up that tougher body exterior, whereas a nautilus, or say a chiton, a tusk, a gastropod, or a bivalve, the mantle is that soft tissue part that either hosts the eyes or would be something that helps to purge the body space in the shell of any sort of detritus or of any detritus or sand. But how the mantle shows on the body does, of course, differ based on the mollusk you're speaking of. Let's jump into the most voluminous class of mollusks, which is gastropods. Gastropods are known as a single shell. That's the easiest way to know them, even though, of course, a nautilus has a single shell or a tusk has a single shell. These guys are a bit different. Their single shell tends to, not always, come in a very specific Fibonacci sequence of growth. What does that mean? Well, it's this mathematical sequence wherein basically a spiral occurs and it starts very small and tight in the middle and grows out bigger and bigger and bigger. If you want to know the math of it, feel free to explore. But here on this shell, you can see the opening wherein the foot of the gastropod would be accessible to the outside environment. And then the body of the gastropod, the stomach, the head, etc., would be present inside of the spiral part of the shell. So this is a really great opportunity to witness the way in which the shell is constructed. And depending on the situation, if the animal is being hunted, they may come all the way up as far up into the shell as possible so a tentacle or an arm can't reach it and get it. Or they may use their foot to hold themselves against the sand to protect their body altogether. It all depends on which mollusk you're speaking of. They're very different. Gastropod, if you break up the Latin words, would be gastro and pod. Well, now we know pod means foot. What about gastro? Gastronomic, does that ring a bell? Stomach. Gastro means stomach and pod means foot. So herein we know, unlike the cephalopod, the foot is closest and attached to the stomach of the mollusk in a gastropod. There are so many different kinds of gastropods. This is just a very light assortment. We have exciting things such as tritons, helmets, olives. We also have cones, turbans, tops, murex, and moonshells. As well as these marine, we also have some land-based shells too, to show the variety, not only in color and shape, but also in density of the shell. The density is a really interesting point. Why would they be different in terms of density? Well, first of all, if you're in the water and you jump really, really deep, as you go deeper and deeper, what happens to the space around your body? It gets tighter and harder and stronger. Pressure. As you go deeper in towards the center of the earth, the gravity gets stronger and pressure builds. So you need a nice thick shell that's going to help prevent the animal from basically being imploded upon. That's just one of the most fun reasons as to why a marine shell is going to be thicker than a land snail. A land snail is going to need a thinner shell to help with temperature changes and breathing. The terrestrial shells, the ones that are on land as opposed to marine shells, are also going to come in a wide variety of colors. One reason for that is, of course, camouflage. Part of protecting yourself from predators is blending in with your environment. So say this could be a nice freshwater snail, or maybe one that lives in areas that are maybe brighter, whereas this one probably lives really with lush vegetation. The most troublesome part for land-based snails or mollusks is going to be drying out. Because they are wet-bodied, they have to provide themselves with a lot of moisture to keep that snail body from drying out and getting, dying. So these shells do a really great job, or rather these mollusks do a really great job of providing extra mantle space for that moisture to build and hold. Looking back to the marine shells, we have this massive variety, which can tell us a lot about the different kinds of mollusks. For example, one of the most popular is going to be the conch shell. There is different kinds of conch shells, and this one would be an example of the queen conch. The pink shell kind of gives us an idea that it's coming from that Caribbean area where we see a lot of calcium in the sand and in the environment. So this mollusk, the cool thing about the conch shell is that as the soft-bodied snail or the mollusk lives inside of the shell, as we've already seen, its foot has something called an operculum. It's a small, tiny little fin, in a sense. Not a fin like you would think with a fish, but it kind of looks like that. And what it does is it drops down and hooks into the sand, giving the mollusk inside the chance to basically seal itself off from access in through the opening from any predators. So if it uses its operculum to drop down, hook in, and the foot grabs hold of the sand, it seals itself as much as possible again. So it takes a lot of effort and strength from a predatory animal to flip it and eat the animal inside. That's where the radula comes in very handy for these animals. Because, for example, the triton here, this is just a very small triton, they can get quite large and is actually the largest gastropod that you will find, which is another reason why it is called triton or the king triton mollusk. These guys get so big that they can eat starfish. And what they will do is use that radula, that hard mouth, to break through the shell, as we saw with the fossil, and then, of course, eat the animal inside. So here you could see this triton could very well come in and overpower, say, a conch of this size. Another version would be the scorpion conch shell, or the scorpion conch mollusk, wherein they use these large spikes. They don't move, they don't retract, but they use these spikes to offer protection by keeping the predator at bay. We see that a lot as well with the murex mollusk. And so the murex has a very spiky exterior shell. And you can see a variety of murex. And this one is especially spiky. And sometimes the spikes get even larger. Large enough, or rather long and large and spiky enough to puncture a softer tissue person, whether you stepped on it, or if it's another animal, say another mollusk, or even perhaps a crab, it could then keep the predator at bay by using its arms out like this. One variety of murex is called the purple dye murex, and we really love to talk about this one because it has, well, very fashionable history. The purple dye murex was collected by the Peloponnesians, and when they found that purple dye would be shot out by this mollusk, quite like you see with squid or octopus, right, shooting ink out to distract and get away from any predator, the murex does the same thing. They eject a purple dye out to protect themselves. Well, the people collecting these mollusks, whether for eating or otherwise, realized this, and they started to use that purple dye to change the linen color of what they were wearing. Well, as you can imagine, word spread, and so did awareness of this new color of linen. And over time, only the most wealthy people could afford to buy this purple linen. And that then separated them from everyone else. Because if someone's walking around purple linen, you know they have a lot of money. Which is how, over time, purple becomes a color that's synonymous with royalty, because only royals could afford the purple. Another great gastropod is going to be the cowrie. Now, of course, we're used to seeing cowries like this, where they have these kind of speckled tops, and that can tell us a bit about camouflage, wherein you would have perhaps seagrass going like this, creating shadows, right? And so they would camouflage beautifully. But these guys, their shell from first appearance don't look entirely like the rest of the gastropods. But still has a spiral effect. What makes cowries so special are these one type of cowrie called money cowrie. Money cowrie were used as actual currency for many years by different groups and cultures. We also see them a lot in West African aesthetics, whether people would put cowries in their hair or wear it as part of their vest, quite literally walking around showing the wealth that they have. This is great to realize that across time and cultures and history, the way in which people would barter or buy or exchange ideas and goods could be very different from the way that we understand it today. Other gastropods are going to look very similar, such as this top versus this turban. They both have that pointy top, and they almost look a little bit like a sideways pyramid. But the different construction, size, and of course location where they're found, the next gastropod I would like to show you is going to be this of a limpet. Now limpets look a little bit like chitons in that they have this open bottom, right? This exposed inside here. And like other gastropods, they have kind of like a sloped pyramid top or triangular top, cone top. Limpets are different in that they live on a rock and they go up and down the rock and they use their radula to scrape bacteria and algae to eat, but they always go home at the end of the day. No matter where they go, they make their way back to the exact same spot almost every night. A fun variety of limpet that I like to share when people are visiting on campus are something called a keyhole limpet. It's a limpet like this with a hole on top. And that hole, I would always ask groups, what do you think that's for? And they say, well, to breathe. No, to eat. Not quite. Turns out that is where the waste product would go at the end of the day. So it would go out of the top. The last gastropod that I want to show you is going to be that of a cone. We find a lot of cones in the Pacific Ocean, and some of which are very dangerous because they have the opportunity to defend themselves with an injection of venom. So they could pierce your foot, for example, and shoot a venom into your foot that could cause very young people or very old people to be in a very bad spot and likely hospitalized. But it's very handy when they're dealing with larger predators from the marine environment. Gastropods, tusks, chitons are all versions of mollusks that use their feet in a rippling effect to move from point A to point B. They kind of ripple like a small wave on the outside to kind of move them forward. So if you ever hear of the dance move called the worm, it's very similar. But hey, these are snails, kind of like worms in a way, but not really. The last class of mollusks that I'm going to show are called bivalves. Now they move in a very different way, and it also depends on which one we're talking about. So we'll get to that in a second. But bivalvia, meaning two valves, are a great way to know that unlike some of these other guys, they have two shells. The idea here is two shells by valve. So these mollusks live inside of the shells that are held together by a muscle called an adductor muscle. The adductor muscle is going to be the muscle that's created between these two shells, the seam. So for example, the scallop, the seam would be here and here. So the adductor muscle holds it together there so that the shells will hinge open and close as needed, whether for eating, for protection, or for swimming, or for just hanging out. But we see that adductor muscle not in all of these, whether it's a scallop or a clam. For example, here, the muscle would be between the two, or even an oyster. This one is a fantastic oyster that makes me think a lot of Halloween pumpkins because of the mouth. But the adductor muscle would open and close. So that hinge is very important. Not only because the hinge opens the two shells so that the animal can breathe through their siphons, right? They have an inhale siphon and an exhale siphon. But they also will use it to see. So a scallop actually has sometimes, this one's held together. sorry. So a scallop actually has 100 eyes. And as they open their shell, these little tiny black dots along the outside will actually pick up changes in shadow, of light and shadow, and also movement. They also have little tentacles that kind of sit out of their shell when they're open like this, that feels movement of water. So if you have a scallop like this open, because it's inhaling and exhaling, and while doing so, pulling in phytoplankton, bacteria, bits of dead mollusks and animals, sea animals, right, and eating, these tentacles will sense the movement of, say, an octopus going by. That big weight, that shadow, will go by, and then it will feel it, and the scallop will then go, whoop, and close as tight as possible, holding its adductor tight, so that the shell now has a very, very tight, thin seam around the front, offering the animal inside lots of protection. Because it's very hard to pry this open when it's being held shut from the inside. So we can see this as well with different kinds of scallops, right? But we also see that with all these different kinds of bivalves. One more thing about scallops is how they move. They will actually use their siphon that's on the side of their shell to breathe in and breathe out very quickly. And as they do so, their adductor kind of opens and closes with them. So it looks like they're clapping their way through the water, which is very cute. Clams, however, have a foot that they will use to kick out away. So when you hold a clam up, sometimes you see this kind of pointy body appendage moving out like this. And that's the foot, and they're trying to kick the sand or kick the water to make some movement to go this way or that way. There are also giant clams in the Pacific Ocean. Now these clams don't move. They don't use their foot to kick around. They stay in one spot forever. And as they get bigger and bigger, they can grow up to about 500 pounds. And they usually stay open. This is, of course, not an example of a giant clam, but they will stay open like this with one giant siphon open as they breathe in. And you can see beautiful colors, that they come in variety of colors. So even though scallops and clams move in different ways, giant clams don't move. And same with oysters. And so because they don't move their whole lives, they have to grow sometimes in very cooperative ways. Meaning if you have a giant oyster over here, and over here, the one inside might have to grow really tall up and out in order to reach the water and the food sources that it needs. So that is one of the ways in which oysters are very different from other bivalves. As I mentioned, mussels also stay still too. They will attach themselves with almost like string-like grabbers onto the rock and anchor themselves down, so that way when the water comes rushing in during tide changes, they don't get washed off the rock. Remember how I talked about how cephalopods and gastropods, well, all mollusks have mantles? Well, mantles are going to be what helps the shell to grow with the animal. It's that kind of in between the visceral mass of the body, the stomach, intestines, right, and the brain, and then of course the siphons, which is the mouth parts, and the radula. All of that visceral mass is held together inside the mantle, which is inside the shell. And so the shell is usually a bit softer in the water, not by too much, but usually enough that it helps to make the shell grow with the animal, because you cannot take the animal out and put it in another shell like a hermit crab. The animal is attached to the inside of the shell with that mantle. And so the mantle is great because when in terms of bivalves, it not only gives space for the eyes of a scallop, but with bivalves such as oysters, if an oyster can't move and doesn't get its body washed out the way a clam might or a scallop might, that sand and grittiness that touches the mantle becomes very irritating. So what the mantle does, because it grows with the animal, it will then start to grow over that particle of sand a little bit more and a little bit more and a little bit more until that mantle grows over the entire piece of sand, and over that entire piece of sand, creating a beautiful little lump or a little hill, molehill. And I'm going to show you the inside of this bivalve, which is beautiful. It has this luminescent sheen, and that comes from the mantle. And so if you see that luminescent sheen and you think about that sand that's been covered over by the mantle, that is how pearls are made. Pearls are little tiny beads of sand that irritate the mollusk, the mantle grows over it, and eventually it becomes its own little thing. So to recap, all mollusks have three things in common. One, they have three body parts: foot, head, visceral mass. They have the mantle, and they are invertebrates. These snails, which is essentially what they are in many forms, though not all, these mollusks will be found in the marine environment, in the ocean. They can be found in fresh water. They can also be found on land. Of course, it depends on which one you're speaking about. You're not going to find an octopus at the shopping center. And mollusks are so old. They are some of the older life forms that we find on Earth, though not the oldest. And they still live and thrive today in hundreds of species and varieties. But one thing that you can also find in common across mollusks that have nothing to do with how they are made or built or grow: humans. We use mollusks in many ways. We talked about money cowrie. We've talked about the ink being used perhaps in pasta or in fabric, in linen, dyeing linen. We also use a lot of shells, especially for their mantles, in jewelry, whether it's pearls or if it's taking a shell and creating something from it. If you've ever heard of a cameo jewelry is often made from shells. You slowly cut the shell down until it gets to that opalescent white inner part of the shell. And then you create the cameo or the profile of the person whose image you're capturing. And that has been found in pendants, necklaces, and other types of jewelry. And of course, shells in their own right can also be found in jewelry such as earrings or necklaces. We talked as well about adorning the body with, say, money cowrie. But I think the most popular human use of mollusks are going to be food. Octopus and squid, used in food all the time, very popular in cuisine that comes by the ocean, whether it's Mediterranean or, say, conch is a very popular one in the Caribbean islands. But we also see bivalves used a lot, whether it's mussels, clams, scallops, or oysters, cooked in pastas, made into a sandwich, or eaten raw. Humans will use mollusks in many ways, but definitely fishing for food has been most likely the most popular. The last part of this talk, though, involves coral, and that is a different animal altogether. Coral is most well known as being a part of a reef or a habitat being a place wherein many organisms live together in symbiotic or other kinds of relationships. Coral reefs are going to be whole habitats made up of coral, and they are hotbeds of life. You see fish as well as gastropods and bivalves living inside of coral reefs. Cephalopods, such as octopus, will definitely go hunting for food inside of a coral reef. But coral is different. It's also an animal. It's not a plant. A lot of times people will think because of the way it grows and moves underwater that it's indeed vegetation, but it's not. It is an animal. And at the base of any piece of coral is a hard limestone skeleton that will attach itself to a rock or some semi-permanent or permanent place underwater. Polyps, little soft-bodied organisms, kind of like a jellyfish, starts to grow. and then they colonize themselves or repopulate, and they constantly grow, and then a piece of coral could have anywhere from hundreds to thousands of polyps making up the full body. Okay. Coral reefs can come in 3 types or 3 growing ways. First, one of the most popular is fringing, which is where the coral starts to grow seaward or out towards the ocean away from land, creating a bit of a buffer between the deep ocean and the coastline. The second is going to be known as a barrier reef. That's where it's growing off a little bit further off land and becomes a barrier or almost like a little wall in between deep ocean and the shore. And the third is atoll, A-T-O-L-L, where you start to have a semicircular or a circular kind of reef bed growing, usually with land underneath, and it forms a bit of a lagoon, like a little lake lagoon inside the middle that has access to the greater ocean. So coral can grow in all different shapes and sizes. You could have larger, wider bits, such as this piece, whereas you can also have thinner pieces as well that grow into little arms and branches. Some coral will stay almost brain-shaped alike, whereas others could look like, well, kind of like a mollusk. This one here has little paper-thin pieces that grow outward, but the top side almost looks like a rippling foot. This is a sand dollar, not coral, kind of like an example of a sea urchin. But we just think they're so cool, so we wanted to include them in the box to be part of the habitat conversation. Coral can come in a wide variety of colors. They can really range from vibrant purples and pinks to greens, and even white as well. That can happen naturally, though coral bleaching is a very big concern, which we'll mention in just a second. The way in which coral grows its colors is through the algae that grows on top of the polyps. They force the algae out. It's called a zooxanthellae, and the algae gets pushed out and its color shows off. Stressed coral, however, whether it's through warming of the ocean, pollution, or being touched, meaning the handling of coral itself or cutting pieces, causes stress for the coral animal, for the polyps. And so what they do is they then shoot all of zooxanthellae off of them, and it's called coral bleaching, meaning they basically are surrendering their vibrancy, and it dies. This is also what happens when you collect coral, which is why it has now been made illegal. And that is because coral is so vastly important to the health of the oceans. Part of how coral eat is by eating the debris that comes through the ocean floor. You see them kind of like filters. Just like plants give us oxygen out here on Earth, underwater, coral eats debris and helps to purify the water, keeping its beautiful stasis for other animals to thrive. So the more coral we have, the healthier the ocean. So I thank you for taking a quick tour with me through the Mollusk Museum-in-a-Box to see not only the amazing varieties of shapes, sizes, and colors, and also lifestyle, but also to learn about the world that lives around us too. Just with any other museum in a box, we hope you enjoyed the hands-on opportunity to explore aspects of life. But if you're watching from a different place, virtually or otherwise, and you're not able to see the hands-on, we hope you enjoyed the close-up looks to kind of get a nice variety feel, even though from a screen. Should you ever want to sit with these mollusks to do deeper research or explore them on your own time, whether in person or virtually, reach out to the museum staff. We're more than happy to help you further your own research and interest levels. And as always, we would love to see you on campus visiting the University of Richmond museums. So thank you again, and we hope you enjoy.